In this project, the purpose is to solve the problems that occur in the Department of Information Technology and Communication (JTMK) because of the COVID-19 pandemic. This project will focus on the design and the development of the prototype for the PKS-21 temperature scanner. The implementation encompasses all the processes involved in getting the hardware run properly in its environment, installation, configuration, and final system testing. PKS-21 temperature scanner aims to help JTMK to improve the standard operating procedure (SOP) by reducing the problem of long queue remotely and other than that, temperature scanner also done automatically. The main advantage of PKS-21 temperature scanner is the ability to gather the information. The lecturers need to collect the details such as student names, temperature, and the time of the students entering the class manually. The latest SOP prevents that the temperature is recorded. By using PKS-21 temperature scanner, students and lecturers only need to scan the temperature, and at the same time, the information will be collected by the face sensor. The similar devices for temperature scanning in the market are costly. With this prototype, it aims to develop a similar prototype that is much cheaper than the ones in the market. There are three objectives of our project. First, to scan the temperature by using IoT temperature sensor. The first objective of this project is to develop the temperature scanner of the prototype. The temperature scanner of the prototype is set using sensors, which could be done automatically whenever the students appear in the area of the sensor. The students and lecturers will enter the class faster, and long queues will be reduced. Our second objective is to store the details of the students, such as names and the time frame for easier tracing. Students only need to scan their face with the temperature scanner. The system will automatically identify the identity of the students and submit the details into the cloud database. Our third objective is to develop a low-cost IoT prototype based on the temperature sensor. In this project, we propose an IoT-based prototype that utilizes Raspberry Pi as the main microprocessor to replace the costly similar devices in the market. It is aimed that the prototype could represent a low-cost device for the designated purpose. And now we're moving on to the scope. This project is limited to the students and lecturers of JTMK in Polytechnic Kuching, Sarawak. To implement the system, project scope is divided into two categories, which are the system scope and the user scope. For the system scope, includes the elements as follow. For our software, we are using SQLite 3 for our database. And next we have Python and image processing OpenCV. For our hardware, we are using MLX90614 temperature sensor. The MLX90614 is an infrared thermometer for non-contact temperature measurements. Both the IR sensitive thermopile detector chip and the signal conditioning ASIC are integrated in the same TO39 CAN. Integrated into the MLX90614 are a low noise amplifier, 17-bit ADC, and powerful DSP unit, thus achieving high accuracy and resolution of the thermometer. The next list in the hardware is the Raspberry Pi 3. Here are the specifications for Raspberry Pi 3. It has an 80-degree field of view. Its supply current is 1.5 mA. The object temperature range is from negative 70 degrees Celsius to 382.2 degrees Celsius. For the ambient temperature range is from negative 40 degrees Celsius to 125 degrees Celsius. It has the accuracy of 0.02 degrees Celsius, and the operating voltage is 3.6 volt to 5 volt. And lastly, we have the Raspberry Pi camera module. For the user scope, we are mainly focusing on the students and lecturers of JTMK. These are the impacts for PKS 2-in-1 temperature scanner, which is it can create awareness about the importance of obeying to the SOPs. Secondly, the information will not go missing. This is because all the information will be stored in a database and is very safe and secure. In a nutshell, our system is different from the ones in the market. Other than its cheaper price, our system includes a face detection, so before a student entering a class, it already marked the attendance as present. And the lecturers do not have to call out students' names in class and can directly proceed to teaching first thing after entering class. Hence, our system is time and energy saving. Our system as a whole is to break the chain of COVID-19 that is actively spreading worldwide.